Section 4.7 is on the quadratic formula. Another way to solve a quadratic equation is to use the quadratic formula. It says that if ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's take a look at an example of how we use that. So here we have the quadratic equation 5x squared minus 2x equals 2, and we need to solve that using the quadratic formula. Notice that in order to use the quadratic formula, my equation has to equal 0. So I'll want to subtract 2 from each side. So that's going to give me 5x squared minus 2x minus 2 equals 0, where a is 5, b is negative 2, and c is also negative 2. So now I just plug those into the formula. So x equals a negative 2, or a positive 2, plus or minus the square root of negative 2 squared, which is 4, minus 4 times a times c, all over 2 times a, which is 10. And let's just continue simplifying that. So x equals 2 plus or minus, now that's going to be 4, and it's actually going to be plus 40, 5 times 4 times 2, and that's 2 negatives makes it a positive, so plus or minus the square root of 44 all over 10. Simplifying that a little bit further, I can simplify the square root of 44, because actually that's the square root of 4 times the square root of 11, or 2 times the square root of 11 all over 10. And I can do some canceling here. I can cancel this 2 and this 2 with this 10, so that'll become a 1, that'll become a 1, and that'll become a 5. Make sure that you can actually cancel both of those numbers with something on your denominator. So I'll have 1 plus or minus the square root of 11 over 5. And notice that that is two roots, that's two solutions, 1 plus the square root of 11 divided by 5, and 1 minus the square root of 11 divided by 5. Let's take a look at another example here. You sell wrapping paper as a charity fundraiser. The equation p of x equals negative 6x squared plus 280x minus 1200 models the total profit p as a function of the price x per roll of wrapping paper. What is the smallest amount of dollars you can charge per roll of wrapping paper to make a profit of $1,500? So in other words, I want p of x to equal $1,500. Okay, and I know that p of x is equal to negative 6x squared plus 280x minus 1200. So that gives me a quadratic equation. And I'm going to solve this using the quadratic formula. So again, I want to make it equal to 0. So I'm going to subtract 1500 on both sides. So I'll have 0 equals negative 6x squared plus 280x minus 2700. Then I just want to plug those numbers into the quadratic formula. A is equal to negative 6, B is equal to 280, and C is equal to negative 2700. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is negative 12. Okay, looks a little messy, but it's going to be okay. So negative 280 plus or minus, and this is going to give me 280 squared is 78,200. This is going to turn into a minus because I have a negative times a negative, which is a positive, times another negative gives me a negative, and that's 64,800 all over negative 12, or x equals negative 280 plus or minus the square root of 13,600 all over negative 12. And when I plug that into my calculator, I get two possible answers because I need to do negative 280 plus the square root of over negative 12 and then do the minus the square root of. So that's going to give me that it's approximately equal to 13.62, and my other value is actually also positive, 33.05. And remember, I'm talking about money. X is the price per roll of wrapping paper, and I want it to be the cheapest that it can be, so it's actually going to be this one here, $13.62. Here's a little chart from your textbook. A quadratic equation can have two real solutions, one real solution, or no real solutions. We call the expression underneath the radical in this quadratic formula, that's called the discriminant, and its value can tell you how many real solutions a quadratic equation has. So let's take a look at this chart here. So the discriminant is actually b squared minus 4ac. If that value is greater than 0, if it is a positive number, then you have two real solutions to the quadratic equation. And it could look something like this. So it could be graphed like this. And remember, your solutions are going to be at these points right here where it crosses the x-axis. So I'm going to have two x-intercepts and two real solutions. If b squared minus 4ac is equal to 0, I'm only going to have one real solution. Because remember, that's going to be a 0 under the square root, and the square root of 0 is 0, so you're going to be plus or minus 0. So you really only have one solution. And that graph of that's going to look like this, and you just have one x-intercept at that point right there. Now, if b squared minus 4ac is negative, you have no real solutions because you're going to have a negative number underneath the square root sign, and we can't take the square root of a negative number. You'll have no real solutions, no x-intercepts, and you can see right here that neither of these graphs cross the x-axis. So let's take a look at an example. We need to determine the number of real solutions of negative x squared plus 14x equals 49. So the first thing I need to do is to make that equal to 0. So I will subtract 49 from each side. Okay, and all I need to do is find the value of b squared minus 4ac. I don't have to do the entire quadratic formula. So in this case, b is 14. So that's going to be 14 squared minus 4 times a is negative 1. And c is negative 49. Plugging that into my calculator, I get 196 minus 196, which is equal to 0. So b squared minus 4ac is equal to 0. Therefore, I know that I have one real solution. And our last example here says that a rocket is launched from the ground with an initial velocity of 150 feet per second. The function h of t equals negative 16t squared plus 150t models the height in feet of the rocket at time t in seconds. Will the rocket reach a height of 300 feet? And explain your answer. So basically what I need to do is say I need to let h of t equal 300. In other words, will my height be able to reach 300? Okay, so I'm going to plug that in. Well, that's equal to negative 16 t squared plus 150t. And I need to make that equal to 0. So 0 equals negative 16t squared plus 150t minus 300. Okay, and so what I need to do is, does the discriminant here have two real roots? In other words, will the graph of this look something like this? Will I have a parabola? I know it's going to look something like that. Will it reach at least a height of 300 feet? Okay, so let's go ahead and I think I'll just go ahead and solve this using the quadratic formula. So t equals b squared negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is negative 32. And I actually kind of cut to the chase a little bit here, save some steps. Plugging that into my calculator, I get negative 150 plus or minus the square root. And when I simplify all of that underneath the radical, I get 3,300 over negative 32, which is approximately equal to, and there are two values for this, 2.9 and 6.5. So yes, so that means that at some point here at 2.9 seconds and at 6.5 seconds, my rocket has reached a height of 300 feet. So in this section, we took a look at the quadratic formula and how to use it to solve a quadratic equation, particularly helpful if you have very large numbers and you don't want to have to try to factor it. We also looked at the discriminant and how we could use that to tell us how many real solutions there are to a quadratic equation.